Hello, ladies and gentlemen. Today we're going to be talking about how to long divide polynomials. Now, over the next couple days, we're going to be talking about all this dividing polynomials, and you might be thinking to yourself, Mr. Guy, you said that we're going to explore all the important information about polynomials. What does this have to do with that? We're going to talk about the reason why we are doing this a little bit later as we go. Okay, so right now, we're just going to focus on the process, and eventually we'll get into kind of the conceptual why are we doing this part as we go along. Okay, so first of all, when we go to long divide polynomials, okay, the very first thing we need to make sure we know how to do is how to long divide, period. Because the same procedure you learned how to long divide in 3rd or 4th grade is the procedure that we're going to use now to do these polynomials, okay? So what I want you to do right now is I want you to pause the video and I want you to try this division problem, okay? So write it out like a long division problem. Do 3 into 307. 639. And again, I'm not as concerned about your answer as I am that you know the process that you're supposed to be doing here. Okay, so think about the process, write down your steps as you go. We'll meet back together in a moment and see if we have the same answer, and mostly just to look at what the process looks like. How do you long divide numbers? Go ahead and do that. We'll meet back in a moment. Alright, so here's how I did my long division. So basically what you're kind of doing is like almost like mini problems here, where you're looking at each number and saying, alright, how many times does this number go into this number? Okay, how many times does it go in? Just to give you guys a little bit of terminology here, some vocabulary. This is called the dividend, okay? And this is a divisor. The divisor goes into the dividend, okay? So 3, the divisor, goes into this part 3 one time. So I put a 1 up here, I write 3 down here, I subtract, I get 0, I bring down the next number, and then I repeat that process again. How many times does 3 go into 0? 0 times, write it down, and I keep doing that over and over and over again. Whatever I have left over at the end is called a remainder. I wrote a remainder of 1. We also can write that as 1 over 3 by putting it over the divisor there, okay? The other way to think about it is almost like, what does this multiply by to give you this number here? 3 times 1 gives me 3. By the time I get down here, I have 7. 3 times 2 gives me 6, which is the closest to 7 I can get. And then in the 16, 3 times 5 is the closest I can get to 16, so on and so forth, okay? So that's how we long divide. Now, what does that mean for us with polynomials? We're going to be doing the exact same thing with polynomials here. How does this go into this thing over here? Oh, this looks really gross. Well, we're going to basically just do the same process we did over there. I'm going to say, all right, what do I multiply x by to get 6x to the third? Okay, how many times does x go into x to the third? What can I multiply it by? So in this case, that's going to be 6x. Okay, I'm then going to go ahead and multiply each of these by 6x. So we're going to get 6x cubed minus 12x. Or 6x squared, sorry. X goes into 6x the cube, 6x squared times. So I'm going to multiply this by each one. I'm going to get 6x cubed minus 12x squared. All right, I almost messed it up. Okay. So that's the thing that gets us to 6x cubed. Now, with the polynomials, what's nice is that that number here should always make it so that these match up. Okay, your goal is to always make these match up. You should be able to multiply by something to make these match up. Okay. Now, I'm going to go ahead and I'm going to subtract this down here. That means I'm going to be subtracting each piece. So what I like to think of it as is I go through and I just change the sign to each of these. Okay, change the sign to each of these. And then I'll go ahead and do my problem here. 6x cubed minus 6x cubed, cancel, get out of here. Negative 19x squared plus 12x squared, that's going to equal negative 7x squared. And then I go ahead and I bring down the next term, which is plus 16x. And then I'm going to repeat and do the exact same thing over again. What do I multiply x by to get negative 7x squared? It's going to be minus 7x. So I multiply those. I'm going to get negative 7x squared. I'm going to get plus 14x. And then again, I'm going to subtract these. In order to do that, I'm going to change all my signs. So this will become a plus. This will become a minus. Over here, get out of my house, you're going to cancel. 16 minus 14 is going to be 2x. And then I go ahead and I bring down the minus 4. And I'm going to do it all over again. What do I multiply by x by to get 2x? is going to be 2. So 2 times x, that gives me 2x. 2 times negative 4, that gives me minus 4. Okay, I'm going to subtract these, so I change all my signs. And for this one, I'm going to get a remainder of 0. This is what you get by dividing these two polynomials. This is my remainder right here. Okay, long division of polynomials. There's my solution there. Here's my remainder down here. Okay? Let's try another one. Let's do another one together here. Here, I'm going to divide these two polynomials. Again, what do I multiply x by to get x squared? In this case, that would be x. X times x, I'm going to get x squared plus x. Let's change all the signs. Minus, minus. These will cancel. 3 minus 1 is going to be 2x. Bring down the plus 5. Okay, so once again, I'm just going to, all right, what can I multiply x by to get 2x? That's going to be 2. That'll give me 2x plus 2. I subtract, cancel. 5 minus 2 is 3. X can no longer go into this anymore, so this will be what my remainder is. So I'm going to get x plus 2 with a remainder of 3. Now, you can also think of writing this like we did before, where we could kind of write this as x plus 1, x plus 2, and then we could say plus 3 over x plus 1. Okay, just kind of like we did in the beginning. If you remember, we got a remainder of 1, and so we put it over here. 1 over 3 was our remainder. Okay, over here, remainder of 3, we put it over the x plus 1. We can kind of write it out there like that. And that's actually going to lead us into one of the things we're going to be talking about, which is called the division algorithm, okay? Basically, it's a way for us to kind of take this division and rewrite everything with this division. So, for example, if I am basically doing a long division problem, where I'm saying, hey, I'm doing f of x, and I am dividing it by d of x, aka the divisor. Okay, so this would be f of x would be my dividend, d of x would be my divisor, okay? I can rewrite all of this, okay, into one kind of big equation, okay? Basically, when I divide these, I'm going to get this up here, q of x, which is kind of my answer, otherwise known as the quotient. And then I'm also going to get a remainder, which is a polynomial, so I'll call that remainder r of x. There's a way to write all of these that they're related to each other. The way that we do that is we say, hey, f of x, your original function, you can get by taking your divisor, d of x, multiplying it by the answer, or the quotient, q of x, and then adding the remainder to that. And that will equal whatever your original function was, whatever your original dividend was, okay? So let's kind of look at what that looks like if I do one of these problems. So let's do one of these problems. Here's our division here. So again, I'm going to say, all right, what am I multiplying x squared by to get 2x to the 4th? That's going to be 2x squared. Okay, multiply each of these by 2x squared. I'm going to get 2x to the 4th. I'm going to get plus 4x to the 3rd. And I'm going to get minus 6x squared. We'll go ahead and subtract, change my sign, change my sign, change my sign. This is going to go away. Interesting enough, this is also going to go away. It doesn't really change my process much, but it does kind of save me some steps here. It kind of gets rid of one whole thing I have to do. And then negative 5 and 6 is going to be negative 1x squared. And then I'll go ahead and bring down the plus 3x. And I'll bring down the minus 2. You'll notice that for this one, we kind of have 3 terms here as opposed to 2 terms with the other ones. So I'm kind of bringing down 2 things at a time so that I have 3 terms to deal with when I go to divide this in, okay? Now, what do I multiply x squared by to get negative 1x? I'm going to multiply by negative 1. So I'm going to have negative 1x squared. I'm going to have negative 2x. And I'm going to have positive 3. Once again, I'm going to change the sign. So plus, minus, these will cancel. I'm going to get 5x and then minus 5. And this is going to be my remainder. So we have 2x squared minus 1, and we have a remainder of 5x minus 5. Now, if I wanted to use what we talked about on the last slide, okay, this division algorithm, I can rewrite my original function by using this right here. So what does that mean for this one? It means that I can rewrite 2x to the 4th plus 4x to the 3rd minus 5x squared plus 3x minus 2. I can rewrite that as x squared plus 2x minus 3, my dividend, times my quotient, 2x squared minus 1, plus my remainder, 5x minus 5. Okay, these two statements are equivalent. They are equal to each other, okay? All right, so that's how we write that using that division algorithm. That's kind of how we can rewrite it so that they're all related in kind of one big equation, okay? So we're getting our quotient, we're getting our remainder, everything looks hunky-dory and beautiful, okay? Sometimes when we go to do long division, we're going to be missing some pieces. So for this one, when I go to divide this, you'll notice I'm missing an x squared and an x term. I'm going to fill those in with zeros, okay? So you have to remember to fill those in with zeros. You need a placeholder for those. And then you can go ahead and do your long division like normal. Okay, so we fill in the placeholders and we do long division. So for this one, multiply by x squared. I'm going to get x cubed minus x squared. Change my signs. Cancel. I'm going to get x squared. We'll bring down the 0x. Once again, I'm going to multiply by x. Okay, we're going to get x squared minus x. Change my signs. Cancel. I'm going to end up getting x minus 1. Okay, and this will go into that one time. We'll get x minus 1, and we're going to have no remainder. These are just going to cancel, so that would be my answer. Okay, and I could rewrite this original equation. So x cubed minus 1 would be equal to x minus 1 times x squared plus x plus 1. This may be giving you a hint about where we're going to be heading with this. Because I have no remainder, there's nothing to add on to this. This kind of looks like I factored it a little bit, doesn't it? I don't know. Maybe something we're going to see in a moment, okay? That's kind of what I have for you guys today. That's how we're going to long divide polynomials. Okay, make sure you follow that process exactly. I would probably reference back to this video as you do some of the practice problems today and on Monday when you do some more, or the next day when we do some more. Make sure that you are looking at this process and going through, and be wary of when you have those remainders, okay? And make sure you change these signs, okay? When you're going through, you're subtracting this whole thing. The way I like to think about that is just change all your signs and you'll be good to go, all right? That's long dividing polynomials. Thank you all for watching.